Hello viewers, I will teach you the relation between differentiability and continuity. In my first class, I have already discussed about continuity and differentiability separately. Now today I will teach you the relation between differentiability and continuity. Let y is equal to f of x be the given function and x is equal to a be the given point. So we have to test the differentiability and continuity of this function f of x at the point x is equal to a. We have already learnt, मैंने बता दिया था कि मेरा continuity class में here is differentiability versus continuity. This is the condition of continuity and this is the condition of differentiability. So a function f of x at x is equal to a will be continuous if functional value is equal to limiting value. That is f of a is equal to limit of f of x at x tends to a, or functional value is equal to left hand limit is equal to right hand limit, which implies f of a is equal to limit of f of x at x tends to a minus is equal to limit of f of x as x tends to a plus. This is the condition for continuity. And the condition of differentiability we have already discussed. हम differentiability chapter में discuss कर चुके हैं. A function will be differentiable. The differentiability of a function can be described by two methods. First method is f dash a. F of x is function. The derivative is f dash x. So f dash a means derivative at x is equal to a. F dash a is equal to limit h tends to 0 f of a plus h minus f of a by h. If this limit exists, then we can say this function is differentiable, or this is same as limit a x tends to a f of x minus f of a by x minus a. If this limit exists, then we can say that function is differentiable at x is equal to a. And another condition, second method is if left hand limit is equal to right hand limit. That is f dash a minus is equal to f dash a plus. F dash x is the derivative at x. At a means f dash a, and f dash a minus means left hand derivative, f dash a plus means right hand derivative. And the formula for f dash a minus is limit h tends to 0 f of a minus h minus f of a by minus h, and the formula for right derivative is limit h tends to 0 f of a plus h minus f of a by h. The difference between these two is here is plus h, here is minus h. So if left hand limit is equal to right hand limit, then the function can be differentiable. So one important thing is this is the condition for continuity and this is the condition for differentiability. What is the relation between differentiability and continuity? The very important thing is every differentiable function is continuous. If a function is differentiable, then it is continuous, but the converse may or may not true. That means if a function is differentiable, then it must be continuous, but if a function is continuous, then it may be differentiable or not. So this can be proved by the help of a theorem. The theorem is if a function f of x is differentiable at a point x is equal to a, then it is continuous at x is equal to a, but the converse is not necessarily true. The given function is f of x. If it is differentiable, then it is continuous. So we will take the function f of x is differentiable to show it is continuous. Now the proof: let f of x be differentiable at x is equal to a, which implies limit x tends to a f of x minus f of a by x minus a exists, and this is equal to f dash a. This exists and this is equal to f dash a. The formula for f dash a is this much, we have already discussed. Now let limit x tends to a f of x minus f of a, f dash a is equal to this much. मैं अभी उसी का वैल्यू निकालना चाहता हूँ. I want to find the limit of this. I want to find the limit of f of x minus f of a as x tends to a कितना है. Now look at here. Limit x tends to a f of x minus f of a. I want to evaluate the limit of this. Now divide here x minus a, multiply here x minus a. Now what happens? Which is equal to limit x tends to a. Look at here. This is a function, this is also a function. limit of f into g is limit of f into limit of g. That means limit x tends to a of f of x minus f of a by x minus a into limit x tends to a of x minus a, which is equal to the limit of this. Look at here, f dash a is this. Limit x tends to a, f of x minus f of a by x minus a. Limit of this is f dash a. So the value of this is f dash a into limit of this is, put x is equal to a minus a is 0 and this is equal to 0. So we find limit of this is equal to 0. That means here, so limit x tends to a. Look at here, limit of f minus g, function minus function. We know limit of f minus g is limit of f minus limit of g. So limit of f of x minus limit x tends to a of f of a is equal to 0, which implies limit x tends to a of f of x is equal to this value. But look at here, this is constant, so x का value इधर नहीं put कर सकते. So this is f of a, which implies this is the limiting value of f of x at x is equal to a. That means this is limiting value and f of a is functional value. So we find here the functional value of the function is equal to limiting value. That means the function f of x is continuous. So we take the function is differentiable and show that the function is continuous. That means every differentiable function is continuous. But the converse, if a function is continuous, then it may or may not be differentiable. We have already discussed. The example is f of x is equal to mod x. I have already discussed this example in my differentiability class. This function is continuous at origin but not differentiable at origin. F of x equal to x mod is continuous but not differentiable at origin. So the theorem says if a function is differentiable at a point, then the function is continuous at that point, but the converse is not necessarily true. One question, test the differentiability and continuity of f of x is equal to 1 modulus of 1 minus 1 by x at x is equal to 1. So ये function का differentiability test करना है at x is equal to 1. So dear viewers, when we are testing the differentiability and continuity, first test the differentiability. If the function is differentiable, then there is no necessity of testing continuity because the function will be automatically continuous at that point. Because we have the theorem is if a function is differentiable at a point, then it is continuous. But अगर एक फंक्शन डिफरेंशियल हो गया तो कंटिन्यूटी टेस्ट नहीं करेंगे, लिख देंगे ये कंटिन्यूस हो गया. अगर एक फंक्शन डिफरेंशियल नहीं हुआ, then we have to test continuity. So first to test differentiability. f of x is equal to modulus of 1 minus 1 by x. So इसका वैल्यू कैसे निकालेंगे? Look at here, mod x is x if x greater than equal to 0 minus x if x less than 0. So mod x is x if x greater than 0. So modulus of this is plus 1 minus 1 by x, 1 minus 1 by x if when x greater than 0. That means this greater than 0. That means 1 greater than a माइनस चला गया प्लस हो गया, which implies x मल्टीप्लाई कर दो x greater than 1 if x greater than 1. So 1 minus 1 by x mod is 1 minus 1 by x if x less than 1. And the second is mod x is minus x. That means modulus of this will be minus of 1 minus 1 by x if when x is less than 0. That means ये less than 0 होगा, 1 minus 1 by x less than 0. And इसे सॉल्व करने से कितना होगा? We get x less than 1. So if x greater than 1, the value of this is 1 minus 1 by x. If x less than 1, the value of this is negative of this, means minus multiply कर दो minus 1 plus 1 by x. So इसको याद रखो, जहाँ भी दिखोगे मॉडुलस वाला फंक्शन रहेगा, ऐसे इसको ओपन करने के बाद तुम सॉल्व करोगे। So in order to test the differentiability, we need these three things: f of a minus h, f of a plus h. I have already said these three things are necessary for the test of differentiability. So f of a means f of 1. F of 1, look at here, this is x greater than equal to 1. So f of 1 means x is equal to 1. So put x is equal to 1 here, put x is equal to 1. If we put x is equal to 1 here, 1 minus 1 by 1, this is 0. Then is f of a minus h, f of 1 minus h. 1 minus h means x less than 1. यहाँ से निकालेंगे. So this function, so f of 1 minus h, put x is equal to 1 minus h here, minus 1 plus 1 by 1 minus h, and this is, यहाँ LCM जाएगा 1 minus h, यहाँ मल्टीप्लाई कर देने से minus 1, and this is plus h plus 1, and this is h by 1 minus h, and f of 1 plus h. 1 plus h means x greater than 1. यहाँ से निकालेंगे 1 minus 1 by x is 1 plus h, and this is 1 plus h. 1 plus h minus 1. This is h by 1 plus h. So after this we need LSD and RSD. Left hand derivative. The formula is limit h tends to 0. f of a minus h means, मैंने बोला था this minus this, f of 1 minus h, this minus this, f of 1 by minus h, and the formula for right derivative is limit h tends to 0, this minus this, f of 1 plus h minus f of 1 by h. Which is equal to limit h tends to 0. f of 1 minus h is this one, h by 1 minus h minus f of 1. f of 1 is 0 whole divided by minus h, and this is limit h tends to 0. Look at here, h by 1 minus h into 1 by minus h, and which is equal to, we find h cancel हो गया, लिमिट h टेंस टू 0 रहा 1 बाय माइनस मल्टीप्लाई करने से h माइनस 1, एंड h को 0 पुट कर देने से ये हो गया माइनस 1. सो लेफ्ट डेरिवेटिव वी फाइंड माइनस 1, एंड द राइट डेरिवेटिव इज लिमिट h टेंस टू 0. f of 1 plus h is this one, h by 1 plus h minus 0 by h, which is equal to limit h टेंस टू 0. सो ये रहा 1 by 1 plus h, and each h 0 पुट करने से 1. लुक एट हियर, लेफ्ट हैंड डेरिवेटिव इज माइनस 1, राइट हैंड डेरिवेटिव इज प्लस 1. सो हमको मिला लेफ्ट हैंड डेरिवेटिव इज नॉट इक्वल टू राइट हैंड डेरिवेटिव. सो हमको क्या मिला, लेफ्ट हैंड डेरिवेटिव इज नॉट इक्वल टू राइट हैंड डेरिवेटिव. सो नॉट डिफरेंशिएबल. सो दिस फंक्शन इज नॉट डिफरेंशिएबल. सो मैंने बोला था अगर एक फंक्शन डिफरेंशियल नहीं हुआ तो वी हैव टू टेस्ट द कंटिन्यूटी. नाउ टेस्ट द कंटिन्यूटी. Now test for continuity. In order to test the continuity, we first need the functional value. Functional value means f of 1. We have to test at x is equal to 1. And here x is equal to 1 means from this value we put x is equal to 1. 1 minus 1 by 1. This is 0. And we get the functional value. Next is the left hand limit and right hand limit. मैं कंपेयर कर देता हूँ. Here is limit x tends to 1 minus h, and here is limit x tends to 1 plus h, and here the function is the left hand limit function, means this one minus 1 plus 1 by x. This will give the left hand limit, and the right hand limit will be found from this value, that means 1 minus 1 by x. And the second step मैंने बोला था, put limit h tends to 0 and minus 1 plus 1 by x की जगह कितना पुट करेंगे, 1 minus h. And here we have to take similarly, here is h tends to 0, here is also h tends to 0, and 1 minus 1 by 1 plus h. Now putting h is equal to 0. After putting h is equal to 0, this is -1 प्लस h0 पर ये 1 हो गया एंड दिस इज 0 एंड हियर इज पुट कर दो h0 पर पुट करने से 1 माइनस h0 हो गया a1 इज 0. सो हियर इज फंक्शनल वैल्यू LHL RHL तीनों समान हो गया, मतलब फंक्शनल वैल्यू इज इक्वल टू LHL इज इक्वल टू RHL. सो f of x is continuous at x is equal to 1. So this function is not differentiable but continuous at x is equal to 1. Next, to test the differentiability and continuity of a function f of x is equal to x square into x mod at x is equal to 0. Now here the given function is x square into x mod. I have already said you have to expand the modulus function, that means this is x square into x or x square into minus x. This is x cube or this is minus x cube when if x greater than equal to 0 and this is x less than equal to 0. Now we can test. The first is to test for differentiability. फर्स्ट डिफरेंशियल टेस्ट करेंगे, अगर डिफरेंशियल नहीं हुआ तो कंटिन्यू टेस्ट करेंगे, अगर डिफरेंशियल हो गया तो देयर इज नो नेसेसिटी टू कंटिन्यूटी, वी कैन राइट इट कंटिन्यूअस. सो इन ऑर्डर टू टेस्ट डिफरेंशिएबिलिटी वी नीड थ्री थिंग्स, f of a minus h and f of a plus h. So f of a minus h, here a is 0, that means we need f of 0 minus h and f of 0 plus h. Look at here, f of 0 means x is equal to 0, x is equal to 0 is here x cube, so f of x is equal to x cube. f of 0 put x is equal to 0, 0 का cube कितना हुआ, 0 cube is 0. And this is f of 0 minus h plus f of minus h. That means 0 minus h means x less than 0. So x less than 0. When x less than 0, the value of function is minus x cube. So यहाँ से निकालेंगे. So f of minus h means we have to put x is equal to minus h here. That means this is minus x की जगह minus h put करेंगे. This is minus h cube. That means this is negative of minus h cube is h cube. And here is f of 0 plus h means f of h, and this function can be obtained then where x greater than 0, and when x greater than 0 the function f of x is x cube, put here this is h cube. Now LSD and RSD. LSD is limit s tends to 0 f of a minus h, a means 0, f of 0 minus h minus f of 0 by minus h, and right hand derivative is limit h tends to 0 f of 0 plus h minus f of 0 by h. देखो मैं कंपेयर करके लिखता हूँ, तुम इसको लिखो बाद में इसको लिखना. लिमिट h tends to 0 f of 0 minus h कितना h cube minus f of 0 is 0 by minus h, and this is limit h tends to 0, this is minus h square, put h is equal to 0, it's 0, and here is limit h tends to 0 f of 0 plus h is h cube minus 0 by h, and this is limit h tends to 0 of h square is 0. Look at here, we find LSD is equal to RSD. So f of x is differentiable, and we know if a function is differentiable then it is continuous, so automatically hence f of x is continuous at x is equal to 0. Now to test the differentiability and continuity of f of x is equal to x into sin 1 by x if x not equal to 0, 0 if x is equal to 0 at x is equal to 0. So in order to test differentiability continuity we have to first test the differentiability. So now test for differentiability. So differentiability test करने के लिए in order to test differentiability there are two methods. Either find f dash a if exists then is called differentiable, or LST is equal to RST. So पहले जो two examples हम solve किए, in first two examples we take the help of left hand derivative and right hand derivative. Now find f dash a. If it exists then it is differentiable. So f dash a, the formula for f dash a is limit x tends to a, f of x minus f of a by x minus a. which implies f dash a इतना हुआ. Now मुझे बताओ if f dash a is this much then what is the value of f dash a means 0. f dash 0 is limit x tends to 0 f of x minus f of 0 by x minus 0, and this is limit x tends to 0 f of x is here x into sin 1 by x minus f of 0. f of 0 means the function of f of 0 means the value of function when x is equal to 0, and when x is equal to 0 the value of function is 0. This is 0 by x minus 0 is x, which is equal to, we find limit x tends to 0. This is x sin 1 by x, which is limit x tends to 0 sin 1 by x. But dear students, in limit chapter we know limit x tends to 0 sin 1 by x is a real number between minus and 1. But what is the exact value we don't know. This is an arbitrary value. But we know limit of a function is unique. But this limit is not unique. That's why this does not exist. So limit of this does not exist. So as f dash 0 does not exist, that means the function is not differentiable. So if this function is not differentiable, then we have to test the continuity. Test for continuity. In order to test the continuity, first we need functional value. Functional value means f of 0, and f of 0 means the value of the function when x is equal to 0. When x is equal to 0, the value of the function is 0. So this is functional value. Then is limiting value. Limiting value means limit x tends to 0 of f of x. This is equal to limit x tends to 0. f of x is here x into sin 1 by x, which is equal to limit x tends to 0 of x into limit x tends to 0 of sin 1 by x, and put x is equal to 0. This is 0 into this value. अभी मैं बोल रहा था limit of sin 1 by x is a real number between minus 1 to 1, not arbitrary, and this is a real number between minus 1 and 1. So ये एक रियल नंबर है -1 to 1, and this implies which is equal to 0 into a real number between -1 to 1. So 0 into every number between these two is 0. So we find functional value is 0, limiting value is 0. That means functional value is limiting value. So f of x is continuous at x is equal to 0. Now to test the differentiability and continuity of f of x is equal to 1 minus e to the power minus x by x if x is not equal to 0, 1 if x is equal to 0. So in order to test differentiability, we test the first method. That means we will find f dash 0. If f dash 0 exists, then it is differentiable. So in order to find f of 0, first find f dash 0, first find f of 0. f of 0 means the value of the function when x is equal to 0. If x is equal to 0, the value of the function is 1. Now to find f dash 0. If f dash 0 exists, then it is differentiable. f dash 0, the formula is limit x tends to 0, f of x minus f of 0 by x minus 0. This is the definition of f dash x, and this is limit x tends to 0, f of x. f of x means this is the value of f of x, 1 minus e to the power minus x by x minus f of 0. We find f of 0 is 1 divided by x, and this is equal to limit x tends to 0. इधर and here LCM जाएगा, limit x tends to 0, here LCM जाएगा x, and this is 1 minus e to the power minus x minus x into this is 1 by x, and which is equal to limit x tends to 0. This is 1 minus e to the power minus x by x into x is x square. So look at here dear students, यहाँ जो लिमिट निकालेंगे by applying L'Hopital's rule. There is a L'Hopital rule. I will say it. L'Hopital's rule is what? This is known as, कभी कभी एल हॉस्पिटल्स रूल्स भी पढ़ते हैं. दिस इज एल हॉस्पिटल्स रूल और लोपितल्स रूल्स पढ़ते हैं। ये लोपितल्स रूल क्या है? लिमिट एक्स टेंड्स टू ए। लुक एट हियर, ये लोपितल्स रूल और ये लोपितल्स रूल और एल हॉस्पिटल्स रूल हम अप्लाई करते हैं लिमिट निकालने के लिए। कहाँ? सपोज लिमिट एक्स टेंड्स टू ए एफ ऑफ एक्स बाय जी ऑफ एक्स हमको निकालना है, बट सपोज दिस इज इन फॉर्म ऑफ 0 by 0, न्यूमरेटर डिनोमिनेटर बोथ 0 हो गया। तो लिमिट ऑफ दिस एफ ऑफ एक्स बाय जी ऑफ एक्स इज लिमिट एक्स टेंड्स टू ए एफ डैश एक्स बाय जी डैश एक्स। दैट मीन्स एफ बाय जी का लिमिट एफ डैश बाय जी डैश का लिमिट के साथ समान हुआ है। f by g, the limit of f by g is limit of f dash by g dash. So here we apply this thing, limit x tends to 0, limit of function by function is limit of f dash by g dash means limit of derivative of f of x by limit of, so limit of f dash by g dash means limit of L hospital's rule is limit of f by g is limit of f dash by g dash means limit of derivative of f by derivative of g. So look at here, इधर क्या हुआ कि देखो x अगर 0 पुट कर देंगे तो क्या हुआ, ये 0 हो गया, e पर 0 is 1, 1 minus 1 0 and this is 0. So ये 0 by 0 फॉर्म हो गया। So याद रखो ये एल हॉस्पिटल्स रूल और लोपितल्स रूल अप्लाई कहाँ करते हैं? जहाँ 0 by 0 फॉर्म में होता है। सो दिस इज इन 0 by 0। सो लिमिट ऑफ एफ बाय जी इज लिमिट ऑफ डेरिवेटिव ऑफ न्यूमरेटर बाय डेरिवेटिव ऑफ डिनोमिनेटर। सो इसका डेरिवेटिव कितना होगा? 1 का 0 एंड दिस इज माइनस इट्स माइनस एक्स इज ई टू द पावर माइनस एक्स माइनस एक्स का कितना 1 बाय 2x। लुक एट हियर, अभी क्या हुआ, अगर x 0 पुट कर देंगे तो e पर 0 इज 1, 1 minus 1 0, अगेन ये भी 0 by 0 फॉर्म आ गया। अगेन अप्लाई लोपितल्स रूल, तो लोपितल्स रूल क्या कहता है? लिमिट x टेंड्स टू 0, डेरिवेटिव ऑफ न्यूमरेटर बाय डेरिवेटिव ऑफ डिनोमिनेटर एंड द डेरिवेटिव ऑफ दिस इज माइनस e पर माइनस एक्स, डेरिवेटिव 1 इज 0 बाय 2। ना लुक एट हियर, अभी ये 0 by 0 फॉर्म में नहीं है क्योंकि डिनोमिनेटर 0 नहीं है। जब तक 0 by 0 फॉर्म में रहेगा तब तक लोपितल्स रूल अप्लाई हो सकता है, लेकिन दिस इज नॉट इन फॉर्म ऑफ 0 by 0। नाउ पुट x इज इक्वल 0, इफ यू पुट x इज इक्वल 0 देन लुक एट हियर e पर 0 इज 1 एंड माइनस 1 by 2। सो लुक एट हियर, दिस नंबर इज फाइनाइट, दैट मीन्स f डैश 0 exists। सो f डैश 0 इज इक्वल टू माइनस 1 by 2, दिस लिमिट exists। So f of x is differentiable. So dear viewers, this was an amazing, interesting class of the relation between differentiable and continuity. Hope you all enjoy, and if it helps you, then please subscribe, share my channel. Thanks.